Today we will talk about the Gauss Seidel method. This is actually an improvement of the Jacobi's method. So alam natin na yung sa Jacobi's method natin, given tayo ng solution na x equals, let's say, 0, 0, 0, 0 for systems of linear equations with 4 variables. Yung first or yung initial nating solution, yun yung gagamitin natin all throughout. Okay? So, this will be our x sub 1, this will be our x sub 2, x sub 3, x sub 4. And then, saka natin makukuha yung second iteration natin. So, we have x sub 1, 1, x sub 2, 1, x sub 3, 1, x sub 4, 1. Ngayon, ang idea behind Gauss Seidel method is that kung nakuha na natin yung new solution, hindi ba mas appropriate na yun yung gamitin natin para i-approximate yung value ng x natin or yung value ng variable natin. So, mas maganda kung gagamitin natin yung new value instead of the old value. So, yun yung Gauss Seidel method. And the solution using the Gauss Seidel method is defined as x sub I of k equal to 1 over a sub double I times the negative summation of a sub ij x sub j k from j equals 1 to I minus 1 minus the summation of a sub ij x sub j to k minus 1 plus b sub I from j equals I plus 1 to n for each I equal to 1 to up to n. So para i-illustrate ang Gauss Seidel method, let's have the following examples. So use the Gauss Seidel iterative technique to find approximate solutions to 5x sub 1 minus x sub 2 plus 2x sub 3 equals 12. 3x sub 1 plus 8x sub 2 minus 2x sub 3 equals negative 25. X sub 1 plus x sub 2 plus 4x sub 3 equals 6. So, hahanapin lang natin. So, uulit-ulitin lang natin yung iteration until such time na makita natin na yung values natin for x sub 1, x sub 2, tsaka x sub 3, meron na siyang ina-approach na number. And whatever number na ina-approach niya, that will be the solution to the systems of linear equation. So for the first step, una muna, gagamitin natin itong tatlong equations na ito para hanapin yung sa first equation, x sub 1, sa second equation, x sub 2, at sa third equation, yung x sub 3. So for the first equation, so eto lang siya, x sub 1 of k equals 1/5 x sub 2 of k minus 1 minus 2/5 x sub 3 of k minus 1 plus 12 over 5. For the second equation, we have x sub 2 of k equals negative 3 over 8 x sub 1 of k plus 1 over 4 x sub 3 of k minus 1 minus 25 over 8. And finally, for our third equation, x sub 3 of k is equal to negative 1/4 x sub 1 of k minus 1/4 x sub 2 of k plus 3 over 2. Note that yung mga k natin dito, they are not exponents. Okay? Kundi sinasabi lang niya na yung k na yun ang gagamitin natin or yung k minus 1. So since na-change na natin yung equations natin into x sub 1, x sub 2, and x sub 3 equivalents, we start with x of 0 equals 0, 0, 0. So ito yung initial solution natin. 0, 0, 0 muna. Pero hindi naman ito palaging 0, 0, 0. It's up to you pa rin kung ano yung gusto nyong piliin na values. You can start with 111, 101, 121 if you like. Okay? But for this example, we will use the initial solution as 0, 0, 0. So our k here, for k0, so we have 0, 0, 0. And then, para kunin yung x sub 1 natin sa first, k equals 1, so gamitin lang natin itong equation na to, and then isubstitute natin yung value ng k minus 1 natin na x sub 2 tsaka x sub 3. Eto yon yung sinasabi niya. Kasi k natin is 1, so yung k minus 1 natin is 0. So eto yung gagamitin natin. So we have x sub 1 equals 1/5. What is our x sub 2 of k minus 1? Diba 0? So we have 0 minus 2 over 5. Our x sub 3 of k minus 1 is also 0 plus 12 over 5. Or that is equal to 2.400. For our x sub 2 naman, gamitin natin ito. So ngayon, sabi niya dyan, ang gagamitin na nating x sub 1 is yung k. So eto na yung gagamitin nating x sub 1. Tapos yung x sub 3 na gagamitin natin ay ito. Okay? Pansin niyo, ginamit na natin yung bagong value ng x sub 1 instead of yung old na value niya. Unlike sa Jacobi's method, ang ginagamit ay yung old value pa rin. Pero for Gauss Seidel, gagamitin na natin yung new value. So we now have negative 3 over 8 times 2.4000 plus 1/4 times 0 minus 25 over 8. And if you compute that, x sub 2 now is equal to negative 4.0250. And for x sub 3, so again, dito, yung new values ang gagamitin. So, ito yung gagamitin for x sub 1. Ito yung gagamitin for x sub 2. So, x sub 3 now equals negative 1/4 times 2.4 minus 1/4 times negative 4.0250 plus 3/2. And kapag kinumpute natin yan, we will get 1.9063. Ngayon, uulitin natin yung iteration natin using the same process. Para naman sa k equals 2, so x sub 1 equals 1/5 times, so gagamitin pa rin natin yung k minus 1. So ito yung gagamitin natin x sub 2 tsaka x sub 3. So we have negative 4.0250 minus 2/5 times 1.9063 plus 12 over 5. At pag kinumpute natin yan, the value is 0.8325. The next, x sub 2, we have, ito yung gagamitin nating x sub 1 at ito yung gagamitin nating x sub 3. So we have negative 3 over 8 times 0.8325 plus 1/4 times 1.9063 minus 25 over 8. And that is equal to negative 2.9606. And for our x sub 3, ito naman yung gagamitin nating x sub 1 at ito yung gagamitin nating x sub 2. So we have negative 1/4 times 0.8325 minus 1/4 times negative 2.9606 plus 3 over 2. And that is equal to 2.0320. So nakikita nyo na ba saan pa-approach yung mga values natin? Okay? At pag inulit natin ng inulit yan, makikita nyo na ito yung kanyang values. So sa k sub 3, ito yung values natin. Sa k sub 4, ito yung values natin. And for k sub 5, ito yung values natin. Which is, alam naman natin ito, approaches 1 na yan. This is negative 3 and this is 2. Therefore, our solution now is 1, negative 3, and 2. Actually, matagal na ginagamit tong Gauss Seidel. However, medyo mas tedious kasi siya kesa sa Gaussian elimination. Okay? Or doon sa systems natin na elimination lang or substitution. Okay? Mas tedious itong process na ito. So for our second example, let's use the Gauss Seidel iterative technique to find the approximate solutions to 12x sub 1 plus 3x sub 2 minus 5x sub 3 equals 1. X sub 1 plus 5x sub 2 plus 3x sub 3 equals 28. And 3x sub 1 plus 7x sub 2 plus 13x sub 3 equals 76. So, ganun pa rin, yung first equation, gagamitin natin to find yung equivalent ng x sub 1. Yung second equation, gagamitin natin to find the equivalent of x sub 2. And yung third equation, gagamitin natin to find the equivalent of x sub 3. And ito yung kanilang mga equations. X sub 1 equals negative 1/4 x sub 2 plus 5 over 12 x sub 3 plus 1 over 12. X sub 2 equals negative 1/5 x sub 1 minus 3/5 x sub 3 plus 28 over 5. And x sub 3 equals negative 3 over 13 x sub 1 minus 7 over 13 x sub 2 plus 76 over 13. Note that the new values should be used to approximate the solution. Okay? Huwag niyong kakalimutan yun sa Gauss Seidel method. So we start with x equals 1, 0, 1. So sabi ko nga kanina, kahit ano namang initial solution, pwede. Okay? So dito, para lang maiba naman, gamit tayo ng 1, 0, 1. So for our first, k equals 0, so we have 1, 0, and 1. For k equals 1, so x sub 1 now equals negative 1/4 times 0. So, ito yung gagamitin natin na dalawa. Plus 5 over 12 times 1 plus 1 over 12. And that is equal to 0.5. For x sub 2, we have negative 1/5 times, so ito ng new value ang gamitin natin, 0.5, minus 3/5 times, eto kasi wala pa siyang new value, so we have 1 plus 28 over 5. And x sub 2 now is equal to 4.9000. For x sub 3, we have negative 3 over 13. X sub 1 is 0.5, so ito yung gagamitin natin. Minus 7 over 13. X sub 2 is 4.9. Plus 76 over 13. So that is equal to 3.0923. So same process for k equals 2. Karon ulit. X sub 1 equals negative 1/4 times, eto ang gagamitin natin. So we have 4.9 plus 5 over 12 times 3.0923 plus 1 over 12. That is equal to 0.1468. For x sub 2, we have negative 1/5 times, eto nang gagamitin, 0.1468 minus 3/5 times, ito yung gagamitin natin, 3.0923 plus 28/5. And that is equal to 3.7153. And finally, x sub 3 equals negative 3/13 times, etong gagamitin natin, 0.1468 minus 7/13 times 3.7153 plus 76/13. And that is equal to 3.8117. At pag inulit natin ng inulit yung iteration na yan, we will have these values. So observe that x sub 1 approaches 1, x sub 2 approaches 3, and x sub 3 approaches 4. Therefore, our solution is 1, 3, 4. For the last example, let's use the Gauss Seidel iterative technique to find the approximate solutions to 10x sub 1 minus x sub 2 plus 2x sub 3 equals 6, negative x sub 1 plus 11x sub 2 minus x sub 3 plus 3x sub 4 equals 25, 2x sub 1 minus x sub 2 plus 10x sub 3 minus x sub 4 equals negative 11, and 3x sub 2 minus x sub 3 plus 8x sub 4 equals 15. So we will use the first equation to find x sub 1 at ito yung kanyang value. The second equation to find x sub 2 and this is the value. The third equation to find x sub 3 and this is the value. And the last equation to find x sub 4 with this value. Let's start with the initial solution as 0, 0, 0, 0. So for our k equals 1, x sub 1 equals 1/10 times 0 minus 1/5 times 0 plus 3/5. So that is now equal to 0.6. For x sub 2, we have 1/11 times, eto na ang gagamitin natin for x sub 1. So we have 0.6 plus 1/11 times 0 minus 3/11 times 0 plus 25/11. And that is equal to 2.3272. For x sub 3, we have negative 1/5 times, ito ang gagamitin natin, 0.6 plus 1/10 times 2.3272 plus 1/10 times 0 minus 11/10. So x sub 3 now equals negative 0.9873. And for x sub 4, so eto naman ang gagamitin natin, negative 3/8 times 0.6 plus 1/8 times 2.3272 plus 15/8. So that is equal to 0.8789. For k equals 2, so we have x sub 1 equals 1/10 times, so etong mga new values ang gagamitin, 2.3272 minus 1/5 times negative 0.9873 plus 3/5, which is equal to 1.0300. For x sub 2, we have 1/11 times 1.03 plus 1/11 times negative 0.9873 minus 3/11 times 0.8 0.789 plus 25 over 11. And that is equal to 2.0370. For x sub 3, we have negative 1/5 times 1.03 plus 1 over 10 times 2.0370 plus 1 over 10 times 0.8789 minus 11 over 10. That is equal to negative 1.0140. And finally, x sub 4 equals negative 3 over 8 times 2.0370 plus 1/8 times negative 1.0140 plus 15 over 8. And that is equal to 0.9844. At pag inulit natin ng inulit itong iteration na to, observe that x sub 1 approaches 1, x sub 2 approaches 2, x sub 3 approaches negative 1, and x sub 4 approaches 1. Therefore, our solution is 1, 2, negative 1, 1.